Reviews. Let's have first our load. Okay, so let's focus sa framing na to. Since ang target is the moment at E at our continuous beam na EFGH at the root level. So we'll consider our frame under this critical division. Hindi naman analyze sa tanang na loadings, one-way distribution. So tanang na loadings na ginari will be carried by your EABCB. Okay, ang aking continuous will be carried by EFGH, one-way distribution. Three IJDL and okay. So for our framing, okay, let's consider our geometry. Bilang atong nang tinatawid? 3.3. Sa framing natin? 3.8. 3.8 plus?
Bali, 3.6 plus
3. 3.6 over 2 plus 3. Plus 3 over 2. This is 3.3. Okay. We'll have our total uniform dead load as our superimposed dead load plus ang aton na sulfate. Okay. So for our superimposed dead load, we will have our floor pressure, total floor pressure, superimposed dead load, multiplied by our critical with bigla na ng ano, superimposed, that is 0.96 multiplied by 3.3. Bilang superimposed dead load natin? 3.16. 3.16. Next, natin na self-weight. Okay, so we'll have the area sa cross-section natin multiplied with our unit weight of concrete. So we will use 23.5 for the unit weight of concrete. Okay, so this will be our cross-section. Our critical width na 3.3 meters. Beam width na is 300. So 0.3 meters. Overall depth, included ang slab natin. That is
600.
0.6. Thickness sa slab 150 or 0.45. Okay. So we need to solve for the area of section natin. Area of cross-section, so let's consider an area sa ating slab. Okay, your area of flange. That is 0.15 multiplied by our critical width, 8.3. Okay, plus 0.6 less 0.15, plan yung bilit.
0.45.
This is 0.45.
0.63 square meters.
0.3. Ilang ating self-weight? Ilan?
14.805.
14.805. So our total dead load, okay, at the beam EFGH, so that is 14.805 plus some 3.168. Ilan siya? 17.97. Okay. Next, our live load. For our live load, we usually have our live load pressure Q. 8 even na siya, that is 2.90 billion. way, ang ating pagsukas ang uniform live load, same sa cumulative load. So that is, uniform live load is equal to our floor live load multiplied by floor live load pressure multiplied in our limited width. Okay, but since this is a live load, there is a possibility na if ang atom na member carrying our live load, kasi tamaan siya kalapat to carry that 2.9 kVA. Okay? So, kindly remember principle sa live load natin. Kaya ba for each square meter, this is 1 square meter, this is 1 meter, 1 meter. Okay? Ang atin na siya na 2.9 kVA. So, ang ga-up per square meter is 2.9 kilonewton. So, if ang atin na loads is tamaan na kagamay, kasi yung mga tao dito, ang total na 2.9 kVA. Okay. So, if ang atin na area na covered is 2.9 kVA is too wide, let's say for this room, let's say for example this room, kaya ang inyong live load is 2.9 kVA, then nag-carry sa inyo as ang inyong column. Manotice ninyo, ang inyong 2.9 kVA is acting per square meter, but this column, ang inyong pag-distribute sa ilong na room is not even, diba? So may possibility, ang inyong column, wala yung kina-carry tanan na 2.9 kVA. Kaya wala nang magpatimog yung tanan. So there is, or there should be a live load reduction based sa iya unitary area. Okay, kung wala nga, need na i-reduce, may possibility inyong live load or inyong occupants is not concentrated within this 1 square meter. O, pero kung lakta ka mo, wala lang ako mag-ikus din ang column. So yun yung column, pwede tayo reduce ang iya total live load na carry. Kaya mo ng principle sa aton nga live load reduction. So, let's proceed sa aton ng code revisions. Okay, section 205.5. Reduction of live loads. So we won't use the alternate method. So the design live load method uses the unit live loads as set forth in table 205-1 for floors and 205-3 method 2 for roofs may be reduced on any member supporting more than 15 square meters. Regardless kung beam or column, unlike sa alternate method na we need to compute for our influence area. Diriya, iyan na concern is ila ang tributary area carried by our member. So if ever it is more than 15 square meters, okay, that is too large. Let's say ang inyong occupant, hindi sila mag-dense within sa inyong beam or column. Okay? So including flat slabs except for floors in public assembly. Okay, so gina-exclude ng public assembly and for live loads greater than 4.8 kVA. Let's take for example, ang atom na Q live load it is greater than or equal to 4.8 kVA. So ang atom na occupants, pwede sila mag-inutok dito. Okay. Specifically, di ba, niya for places in public assembly. So let's say yung public assembly is 4.8 kVA. So there are higher chances na ina siyang 4.8 kVA. Ano siya kadamo? Pwede ko sila mag-utok. Let's say mas magkapikay sila. Kaya public assembly mo. So pwede na mas utok sila. So inyong live load distribution under this column or under this beam, mas makarry ang 100% sa inyong loading. So that's why hindi kinanglan sa inyong live load reduction. Kaya na live load, pinakarry directly by your structural member. If ever mas dense, okay, or greater than or equal to 4.8. Okay, since ang ating live load is 2.9 kVA, so there is a possibility na pwede na siya i-reduce. But anong concern natin? So let's check first. Check if live load reduction is required. Okay, anong kinanglan natin? The tributary area carried by our member EF. Okay, our BPF. Okay, let's refer to training plan na. How to compute for your tributary area namin? Diba this is our tributary width? This is the tributary width of our frame. Siyempre, ang ina-analyze ng member, this is our BPF. So, iyan ang tributary area is under this zone or this is the tributary area for our gate here. Pila na siya?
3.3 times 3.5.
That is 3.3 our tributary width. 3, 0.5 multiplied by 8.3 meters. Pila ni? 28.05 square meter. And this is greater than pila? 15 square meter. Therefore, live load reduction is what if ang atong live load pressure is 4.8, do we need to reduce this than greater than? Okay, no need to reduce if greater than or equal to 4.8 kPa. Anong mga best example sa inyong location sa building na may mga greater than 4.8 kPa? O let's say, nila sa engineering building. O, except sa classroom, di ba? Kaya hindi man lang 100% occupied na rin.
Lobby.
O, lobby, ang hallways. So, pwede siya maging more than or greater than to 4.8 kPa. So, you must consider 4.8 kPa sa mga common areas. Stairs, napagin, ang atong engineering lobby. So, pwede siya maging more than 4.8 kPa. So, hindi siya pinagdan pag-reduce ang inyong total. Okay, so let's go back sa code natin. Okay, under the code, if ever ang atong typical area is more than 50 square meter, we'll have our reduction rate in R. In R, tawag ako, this is the reduction in percentage. Okay, as defined by R multiplied by A minus 15. So for every excess of square meter natin, sa 15 square meter, we need to have a reduction rate na small r. This is the rate of reduction. So this is equal to 0.08 for floors and for roofs. Take note na ang atong hina-analyze ng floor level is the roof level. So we'll consider the roof level. Okay? So our rate of reduction, so this is R equal to small r A minus B. Okay, so we already have our A. So A natin is our tributary area, that is 28.05 square meters. Okay? Ang atong na rate of reduction R. Okay, so since this is the roof level, we'll consider table 205-3, minimum roof live load natin. A ating rate of reduction natin. So let's check first our roof slope na parameter. So if ever ang roof tile is flat, or ang iyang rise is less than 1 unit in vertical, or 1 is okay, then we'll consider all parameters under the rate. Since ang roof tile is a roof deck, so this is a flat roof, so we'll use a rate of reduction na nila, 0.08. Okay, so the total rate natin in percentage is 0.08. Okay, total area is 28.05 minus sa 15 square meter natin. Ilang R na? 1.044. Okay, ano yung balik ko? This is in percentage. So this is 1.044%. Ang need na reduce from our total live load. Okay. Answer na hindi pa. Under the code, dapat niya, the reduction shall not exceed 40% for members receiving load from one level only. So since ang atong structural member is a beam, ang iya carrying na level is only the service floor na kung dito siya located. So that is a structural member receiving from one level only. Okay, so ang atong na R-max. So let's check. Bali sa R-max natin. So R-max na is equal to ilan? That is 40%. Shall not exceed 40%. So this for members receiving from one level only. But if ever columns ang inyong ina-analyze, that should not be greater than 60% or as determined by this equation, no? Equation 205-2. So since both values ang inyong 60%, kada inang equation ng 205-2 are all maximum values, you shall select the minimum value between that. Okay? Okay, since ang ating member is only receiving from one level only, so we'll use 40%. Okay? And this is less than sa ating na yung gamit, no? Therefore, okay ang ating na. Okay? So So we'll have our R as 1.044%. So what would be our final QL? So let's use the term na QL. Okay, this is the unreduced natin. So final na QL, hindi ko na siya rin po ang QLO. Ikuha ko sa inyong alternate method. Hindi ba yan ginagamit?
LO.
QO.
LO.
Oh, LO, di ba? Sunod ko lang. UL is equal to ULO. Okay, this is not found in your NSAP. Sunod ko lang pinagbaga ni live load na alternate. ULO, this is the rate of reduction. So, paano na siya i-express ang final na value for our live load? So, it's equal to 1 minus ang aton na rate of reduction. Ay, sorry. Greater than. Okay. QLO ta, in the unreduced, this is 2.9. Less ang aton na rate of reduction. Kita is in terms of percentage, so this is 0.01044. Gamay lang yung reduce, no? Ilang QL na? Two point 86907. Wala na. Okay, so let's solve for our uniform type 2. Okay, that's 2.8697 multiplied by 3.3. Ilang uniform type load na acting at our BPM? Pabayad ko na to?
9.47.
9.4.
7. 009. 009.
009 or 01. Uniform per load. Okay? We now have our dead load and light load. Okay, let's try to present this in terms of our load distribution on your framing plan. Okay? So for this problem, okay, we consider our longitudinal frame. Lato ka floor level, ano isa. Roof deck, third, second. So, ano, di ba? May girder kamo sa roof, may girder kamo sa third floor, may girder kamo sa second floor. So, wala girder sa ground floor. Kaya ato na floor slab sa ground floor will be carried directly by your ground level. So, hindi kinanglan si suspended beam. Okay? Ang mga common na design sa ato ng mga buildings, ang ilang ground floor is not carried directly by your ground floor beams. Kaya nga, ang ka pa sa beam, kung ang inyong slab is na-carry sa inyong soil. Okay, ano mga instances, sir? Ano mga instances? Okay? Ang ginanglan may beam sa ground floor. Anong purpose ni beam? Diba that is a suspended beam. So ang atong na slab, ang carry sa inya directly is your beams. So ang inyong ground floor slab, or commonly known as SOG, that is slab on grade, ay ang carry sa iya all throughout sa iyang span is ang inyong ground floor. Ang mga sa mga buildings, before magbuhos ang ground floor, nilang nukula, compact nilang soil. If ever ang inyong soil is uncompacted siya, magpunta sa inyong loads dali, may possibility ng inyong ground floor slab is masalili. Pwede siya
displace.
mag-compress ang soil, so pwede mag-crack ang inyong ground floor slab. Okay. Isa na naman, Sir Mambal, ang kinanglan namin sa beam under sa ating ground floor level. O let's say, inyong soil profile, let's say sandy siya or clayey. Tamaan siya kahubog or ilang iyang soil bearing capacity, hindi ang makaya ang inyong ground floor. So, kinanglan na punta sa inyong ground floor beams. Okay, ang best example sa mga previous projects is ang smile residences. Wala sila sa SOG. Ang luta sa smile residences is purely sand. Tapos ang ilang water table is taas. So, kita din na soil profile at ground level is not enough to carry your loads, no? Yung carrying loads at ground level. So, ang ilang lupa, ang butang sila sa suspended beam. So, ang ilang na beam sa ground level, wala siya na-rest on ground. Gina-assume nilang suspended beam siya na wala pulos ang luta sa dati. Okay? Kaya ilang ka sa Tagalog is too soft to carry our
Reclamation area.
kaya naman tabo, di ba ta? Di ba this is your ground? Taman ka hulog inyong nga ground level at ari inyong nga SOG. If ang inyong nga soil is uncompacted, this can i-compact yung soil. Okay, there is a topic sa inyong soil mechanics later on that is compressibility of soil. Okay, that is the ability ng soil ninyo na kung mag-apply ka mo sa loads, ilang percentage na makompact siya. Aside sa inyong rate of compaction under your relative density. Ilain sa compaction of soil Lain sa compaction of soil, lain si compressibility of soil. Si compaction of soil is ginabuhinan ng voids within your soil profile. Si compressibility is, let's say, na-compact ng inyong soil, ilang rate niya na mag-induce strain. May strain ka lang, ma-change ang iyang total volume. Okay? So if ever ang inyong soil is na-compress, nanawag ang soil, no? So, hindi siya automatically na mag-lusdak ang inyong ground floor. Ano matabo din ma-form the cracks. Sino naka-witness mga structures ng ilang ground floor level, may mga tiles na gano'n. May kasaka na tiles, may paano galugog na tiles. Anong mga tendencies or anong possible cause na gano'n na? Ang possible cause niya una, kasi wala na compact ang ground level. Ibuhusan lang din yan, wala na sa activity, no? Ibuhusan lang. After pila ka years, nag-crack ang ilang ground. Second, may swelling na rin. Diba kung mag-apply ka sa loads, naka-compress siya. May possibility naman yan, ang inyong soil dere is uncompacted. Tapos, may seepage ka mo. Okay. Ang inyong soil is masudlan water, may maswell siya, mahabog ang soil sa babaw. Pwede mag-crack, masaka ang inyong may swelling, siyempre may voids sa inyo nga ito, soil particles. So pwede siya masudlan sa water, thus pwede siya mag-swell. Kaya mo na mga common cases. So gina-avoid na siya if we will put a ground floor table. So depende sa inyong soil profile, if ang inyong soil profile is deep enough man to carry your gravity loads, pwede ka mo ka-decide na punta nila sa SOG. Anong disadvantage if wala ka mo sa field? Ang inyong column from the top of footing going to your second floor level is too long. Ang kalabang inyong beam na may possibility siya maging slender column. Okay, so ang iyang internal effects, ang iyang mode of failure is not purely due to the internal axial forces and bending movements. Okay, so there is a possibility na if this is a slender column, niyara ka mo sa secondary movement. Okay, pwede siya mag-backball. Amo na nga sa inyong columns, niyara sinatawag na Euler's buckling load. Okay, that is not only limited no, sa aton nga steel columns. So ang aton nga concrete columns, experience mo sa aton nga slenderness. Okay, so hopefully no, we'll have enough time to discuss slender columns. Yan, slender columns sa column, asa ng concrete. Okay, wait that. Okay, so that's all. Kapila columns na rin, apat.
Sway ng column.
Sway ang column. Ano nasa sa panday, nasa panday.
Weak ang formwork, sir.
Ito ako mas.
Tapos nila.
Ito kalang ko mas.
Abot na
So since ang aton nga floor framing diri, this is a typical floor framing. So ang aton nga dimension sa aton nga member same. So ang aton nga self-weight same all throughout. Then ang aton nga superimposed is typical framing na siya. So same na aton nga superimposed dito. Thus, ang aton nga load distribution for our framing na 17.978 same at all per level. So ano mga possibilities sir na kulainay ni? O let's say, inyong roof deck, may banda mga dead load na rin na ibutang. O ano mga examples ng dead load na pwede ibutang sa roof deck. O let's say, inyong roof deck butang ano sa waterproofing. So may ara ka mo sa waterproofing membrane, usually ginagamit nila is ang asphalt. So may ang asphalt na gina-torch, mga torch membranes. May ang asphalt na gina-rolyo lang, ina-apply ko directly. So there are emulsified ng asphalt na ginagamit for roof deck. Siyempre, yung roof deck is flat. There is a possibility, no, na kung magulan, matumpok ang tubig sa babaw, so ang inyong concern dali, base magtagas ang tubig from your roof level. So minobra na, inamutangan sa waterproofing sa babaw, so lain ang inyong agad load sa roof level. Tapos after sa waterproofing, ginamutangan sa concrete topping. Try to check ayala sa roof deck nila. Okay, usually waterproofing is color black. Yung ginagamit guys asphalt. Tapos after na, this is your slab. Okay, ma-apply sila sa inyong waterproofing membrane. Sino makita paano mutang asphalt to sa dagat? Di ba may ginamit? Kaya mo na siya ang pure asphalt. May masang cutback na asphalt. May masang emulsified. So let's say this is an asphalt ninyo. Tapos after na, pinamutangan sa concrete topping. Okay, para hindi maguba ang inyong waterproofing. So ang inyong roof deck level, ang possible ninyong deck load, aside sa inyong superimposed na additional dira, hindi ba may makisabi sa dalog? So this is your ceiling, tapos may mga pipes na kamo. This is your mechanical duct allowance. So may dugang ka mga waterproofing kag concrete topping para sa inyong roof deck. Kaya ang ating assumption dere, same lang ang dead load all throughout. So for our load distribution, we'll have a uniform load dere. That is 17.973. Same dere. So, ang example sa inyong load distribution for your longitudinal frame for the case of the load. Ang muna ang sure sa inyong framing system. Ito, tingnan ito. Ang inyong beam EF, ang beam na i-analyze. Next, live load tag. Siyempre, in live load tag, there will be 3 cases. Yung mga kasi CERCDN ninyo, bilang cases nila ninyo, hambal yung 3 lang, 800, 75, tag, 50. So for this problem, for our live load, we will only consider one live load case, that is 100%. These are ang 0% na live load case. So syempre, dead load lang yun, kaya wala live load. Dapat wala sa 0%.
Sir, kung tatlo ka live load ang i-consider, ang maximum ang pilihan?
Hindi.
Ang ano man?
I-analyze nyo bitatanan.
Ang tama, pinakala ko ang moment.
75, 50.
Ano mo ito ang mga live load patterns? Ang tama, pinakala ko ang moment.
Moment.
So let's consider as same occupancy of
Susunod mo lang daw.
Ano
Isa share.
9.4701.
Gets ko na.
Nagana ng idea, anong browsing, mga perfect study?
Maluto pansit, sir.
Maluto, pancit, canton. Sweet and spicy, tapos
May
ano
itlog.
na yung ice cream?
Sir, paano i-load combi kung tatlo yung case, sir?
Sa isawan, i-explain ko later.
Ito lagi nakapagpos.
Basta long keep.
Timatapos din, no? Timatapos din.
Sa na wind load.
Sa wind load.
Let's have our BEF.
Sa na ang wind load.
Sir,
Naging earthquake.
paano ang principles of load combination? Okay, we don't combine our loadings. Instead, may dumdum sa aton na 6 degrees of freedom sa internal member natin. Wherein we'll have shear, duwang direction, axial, tapos bending moment about strong, bending moment about weak, tapos ang aton nga torsion. So in order for us to combine these effects, kinanglan ang load combi that is the internal reaction produced by this load case sa inyong member. What sa inyong load combination, wala na combine sa loadings. Kaya ang atong i-combine is the internal reaction. Dumdum ko sa inyong concrete, kailangan bilog ang ito gina-analyze. First, let's have our MU, VU, EU, CAG, Okay? These are all required strengths from your load combination. Okay? Pwede din inyong MU, okay? 1.4 moment at dead, or 1.2 moment dead plus 1.6 moment light, and so on. Okay? Ang ato nila combine is the internal reaction. So let's say, if you are designing your EF as a flexural member, so kinanglan ninyo ang inyong factored moment or the required moment na MU. Okay? Ano yung problem? Ang atong PRCD, we are only dealing with dead load, live load. But in our analysis, syempre, we have introduced our seismic and wind loads. Dapat i-consider ta kung anong moment produced at the same location sa inyong lateral load. Syempre, ang initial inyong dead load, may moment produced at your beam EF. Okay? Di ba syempre yung moment, tama di ba? Same as ato nga, live load. Kasong problem, this is an indeterminate frame. Okay, this can be analyzed directly by statics. Yung ang atong target for the problem is to identify ilang moment acting at the support chain. Paano na sumahod? So we have introduced earlier ang atong structural analysis methods. We'll have our determinate ng mga methods, okay, using statics. We'll have our indeterminate, so we will have approximate method. Important na deliver. Then ang inyong theory 2, indeterminate analysis, MDM, SDM, moment, and other na introduced na method. And last, for our gravity loads, we'll introduce NCP 2015 provisions for continuous beams and slabs. Okay, para masapos siya i-analyze. Okay, kindly open section 406. Extend. So, katilayan, EXT as render. Extend line. Okay. So, we'll have NCP provisions for continuous beams. So, what do we mean by continuous beams? Ang atong na beam is the continuous. Okay, ang iya na support is, I mean, ang beam is supported all throughout. Okay, wala siya na-terminate at each support. I mean, this beam, ga-act siya as not an individual beam direct. Ga-continue siya all throughout. So, ang iya span is supported at each location. For 406.5.1, okay, so it shall be permitted to compute or calculate MU and BU due to gravity loads. Okay, kasong problem na rin, since gravity loads lang ang present sa ating loading, so that the light. Okay, but instead, we will introduce our seismic with load. So we won't compute for the factor moment, but rather, i-analyze natin ang internal moments produced with our dead and live using this equation. Okay? So this is only applicable for continuous beams and one-way slab satisfying A to E. So we will have our 5 provisions. So first, members are prismatic. So what do we mean by prismatic? Ano mga bang prism?
Geometry.
Ng prism? Isuhan. This is our section, per section. No? So if umon mo ni siya, okay, over the length L, same Japon ang aton na per section. Okay, it will have our section diri, same also throughout sa length natin ang area of the section. So this is a prismatic member. Dumdum ko sa inyo ang strand of materials, syempre wala. Na diba, consider the beam is prismatic. So wala ka change ang dimensions ng inyong beam, or I mean, ang iya section all throughout sa iyang end. So dapat ang atong mga beam members, same ang ilang dimension all throughout. Second, loads are uniformly distributed. So we can apply this sa atong load cases na rin. And we don't have live loads and, we don't have concentrated loads acting sa atong EFGH. Okay, let's check ang aton na service live load. This must be less than or equal sa 3 times ang aton na service live load. Okay, for provision, there are at least 2 spans. So we'll have 3 spans, so applicable siya. Then the longer of 2 adjacent spans does not exceed the shorter by more than 20%. Okay. So for this problem, ang aton i-consider na length is our clear length. Okay, so we'll have our clear length, Ln1. We'll have also clear length na Ln2. Clear length na Ln3. Okay? Ang ating mga movements are acting directly at the face ng ating mga column. Okay, ang shear same man. So let's complete for our Ln1, Ln2, Ln3. Ln1, okay, this is 8.5, no? 8.5 meters is measured on center. So we must reduce, no, the width ng inyong column. So this is 8.5 less ang ating column dimension na
450 by
450. So 0.45 over 2 minus 0.45. Pilangan ng Ln1?
8.05.
8.05. Ang atong na Ln3
Equals.
same as the that is 8.5 also. This is 8.05. Ln2. Okay, on center spacing is measured as 7.2. 7.2 less 0.45 over 2. Sino wala na ka-gets na 0.45 over 2 ang gina-reduce? Ilan?
6.75.
6 point. Di ba ta? Ano siya? Usually sa floor plans, ang ilang inahatag ng measurement are measured from the center sa column. Okay, based on given, there are 8.5 ang iyang matapos isa. This is your 8.5 meters. Ang kinanglanta is ang aton na clear span between the face and column ninyo. So we'll have column dimension, this is 0.45 over 2 kay half niya. Tapos, 0.45 over 2. Okay, most of your floor plans, ang ilayahatag is on center spacing. Okay? Ano next, so let's check if section 406.5 is applicable. Okay, kaya ang ating analysis, we will compute for the moment acting at pointing. Okay, liwata ako na i-load convey the moment at ilang get. If may enough time, syempre na nga moments, di ba? I-load convey natin. Ano mga particulars natin? First, for letter A, that is, members are prismatic. Therefore, members are prismatic. So this is satisfied. Satisfied. Sir, panawalaan if prismatic. Wala ka change ang dimensions ang inyong beam all throughout sa inyong second. Letter B. Loads are uniformly distributed. Loads are uniform. A, this is satisfied also. Letter C. L is less than or equal to 80. Ano siya nga L? This is our service load. So this may be expressed kung we are loading sa uniform load. This can be expressed also sa moment. This can be expressed also sa shear. So since ang available din na loading is in terms of uniform load, both sila same sila may uniform load at this level sa roof deck ninyo. So let's compare our uniform loads. Okay, so we'll have our uniform load. Okay, so let's check if this is less than or equal to 3 times ang ating na uniform dead load. So uniform live load is 9.4701. So 3 times uniform dead is 17.973. Pilan eh? 53.919. Okay. Therefore, satisfied ka. Or okay ka gusto. Satisfied. Fourth provision, there are at least 2 spans. So we have 3 spans. Paano rin matawag continuous beam if isa lang span? Simple span lang siya, kay one span lang siya. This is a continuous beam. Ano mga basta continuous beam mo? Ang inyong beam is supported all throughout sa iyang length. Okay, continuous siya. Okay, there are some assumptions yung ilalim na obra. May pin ka din, tapos isubkon mo naman sa piyang. This is not a continuous beam. Tinututunan mo siya kung i-assumption. Okay, ang assumption na is continuous siya all throughout. Okay, so there is a moment distribution between the ends ng inyong beam. Okay, amo na siyang inyong continuous beam. Dumdum lang sa inyong sa din siya ni best applied superposition method na may mga internal rollers na mo. Here ito. Base spans. Span siya, therefore, satisfied natin. Last provision, the longer of 2 adjacent spans does not exceed shorter by more than 20%. Okay, so we have 3 spans today. Si LN1, si LN2, they are adjacent spanay. Si LN2, si LN3, they are adjacent because they are spanay. Ito ba tayo sila? Okay, so since ang atong na LN1 and LN3, same length sila. So let's compare one lang of both sa atong na LN2. Okay, so this fifth provision, the longer of 2 adjacent spans does not exceed the shorter by more than 20%. Paano na? So we'll have length sa longer span. Ito. Tapos ang ba niya? Does not exceed the shorter by more than 20%. We'll have L short. Then tayo compare. Sa long or sa short? Ang bal niya does not exceed the shorter. I-compare ka sa aton na length sa short. Takto na Takto na does not exceed the short. So this should be greater than, sorry, does not exceed. So less than or equal to 0.2. Sakto na The longer does not exceed the shorter span by more than 20%. Check natin. Ang longer span natin is ang 8.05. Okay, ang shorter span na is 6.75.
Clear span din na sir, hindi siya sa ano.
Clear span. Submission. 0.1925. This is less than 0.2. Therefore, satisfied ka ang fit.
Tignan di pa sa test 5 sir.
We can use this solution. Gamit na mo MDM. I-make sure talaga na perfect nga ako gamitin ninyo. Okay, this is a board exam trend, what? Bago naman na topic. Nagbuwan sa boards.
Lapit na lang hindi satisfied.
Paano ni sir? Kindly proceed to table 406.5.2. So for our uniform loads, okay, for our internal shear and internal moment, so we'll have the following coefficients. Okay, so they are the approximate moments for non-piecewise continuous beam and one-way step. Okay, ang iyan gamit is MU. Okay, but instead, kung pramunta, kay din si Pac kasi dead kasi live load. Okay, let's consider this as our moment dead or moment live. Okay, basta as long uniform mo siya kag-gravity load ang inyong loadings. Okay, so we'll have 2 types of moment. We have positive moment and negative moment. Okay, so for our continuous beam, Let's draw our movement diagram. Siyempre, this is a continuous beam. We have a negative movement, positive movement. Muning ating nga movement. Okay, so for positive movement natin, we'll have two locations. So, ang atong slide dire, unahan lang yung positive, tapos ang negative tag, tapos left to right. So, for positive, we'll have end span location kag interior spans. So, alam mo kang baka end span ng interior. So, we'll have three spans. Aking mga end span natin. End span ni iara sa outermost. This is also an end span.
N.
Tapos may interior. Okay, what if, sir? Ang amon na span is wala kabilo. May interior, wala. Wala na nakamong scenario. Kaya hata mga assignment after nito.
Oh!
Oh. Assignment. Let's say two spans. Anong sa? End span eh. End span hindi. Wala ka sa
Hindi mo
interior.
naman satisfy, sir.
Ha?
Hindi mo naman satisfy.
Hindi. Ang minimum niya is at least two spans. What if apat? Okay, end kadere, end span, apat din. Apat. Okay, mo ko paano? End span, this is interior. Gets. For our end span, we'll have a condition. Dua bilog, no? Discontinuous end, integral with support. Discontinuous end, unrestrained. So what do we mean by discontinuous? Anong best examples ng discontinuous? Okay, ang inyong span, wala sa mga subboundary of cantilever. Okay, nakat na siya mismo sa inyong column. So for discontinuous end, integral with support, so what do we mean by that statement? Ang aton na beam is monolithic with our column. Ang second condition, discontinuous and unrestrained. Anong mga best example if ang inyong beam is unrestrained at the discontinuous end?
Cantilever.
Ano? Siyempre, ang ating mga column, pinabuhos, di ba? So, ang iya na end is a integral with support. Okay, so what do you mean integral? Antiderivative. Ang integral is, there is a moment restraint na kung ganyan mag-rotate ang inyong member. So there are cases naman, ang beams nila, so nakakita din gintong-tong sa hollow blocks. Masonry wall na eh. Seryoso to. Masonry wall. Wala din buhos ha. So magtungtong ang inyong beam, paano siya mag-behave? So simple span, di ba? Wala ka sa wala ka sa connection dali nga magtugong siya nga mag-rotate. Therefore, this is unrestrained. Unrestrained. Okay? Kaya ang imo nga discontinuous end, okay, wala ka tugong siya mag-rotate. So therefore, this is a simple support. Wala ka sa end moment dali. So since ang aton nga connections are all fixed end, they will use discontinuous end integral with support. Okay, so for our moment rin, this is W. Okay, W ang atong na-span is ln1. ln1 over pila. That is 14. This is
Squared?
also an
Squared
L
gurong L, sir? L squared, sir.
Squared. W ln3 squared over 14. Then for our interior spans, all conditions, so we'll have W ln2 squared over 16. Masuma mo ng imo nga moment. Okay? O unlike simple span, ang WL squared over 8, this is a continuous beam na may negative moment na. Tapos na diba? Positive. O negative na. For our negative movement, we'll have 4 locations. Interior face of exterior support. Exterior face of first interior support at face of other supports. We'll have supports. Di na support sa kanila. 1, 2, 3, 4. So, apat na supports. So, may ara siya ng tawag nga exterior kag interior support. Muna tayo una. So, this is an exterior support. Support na 9. Exterior support will have also exterior support. Okay? Then we'll have interior support. May interior support sa dali. Muna tayo 9. Two types of location sa atong support, exterior kag interior. But sa atong support, may duwa pa moment nag-exist. Okay, so if ever interior support, kaya ka sa exterior face, okay, this is your exterior face, kay mas lapit siya sa exterior side, okay, this is the interior face. O same dire, ang ining interior support, may exterior face near the exterior side kag interior face niya. Tapos, sa exterior support natin, may aha siya sa iya nga interior face. First provision. Interior face of exterior support. So this is only applicable to supports na aha sa outermost parts ng building, either left or right. Then ang exterior support, dire, isa kag dua. And ano ba niya? Interior face. So syempre, isa ng ibang face din na may moment, lang man. Interior side, interior side. Okay. Goods, the location. Next condition, duwa available. Member built integrally with supporting spandrel beam. Second, member built integrally with supporting columns. Okay, there are beams. So what do you mean with spandrel beam? Dum-dum ka mo sa inyong lecture portion. Let's say niya ka mo sa girder dali. Top view niya. May girder. Girder dali. Wala ka mo sa column dali. Okay. Ano yung rason mo walang column? Kaya ang bagay architect, hindi gusto may poste, may butaman mo sa main entrance dito. So wala poste. Kaso, ngayon siya naspan naman siya kalapad. So butangan mo sa intermediate beam. Okay?
Go on, sir.
Same. Sa dalawang sa engineering lab, may makitaan naman da. May girder tapos may intermediate beam. Sa inyong exterior girder, tapos ito tumaebi may poste ka dito. Poste. Wala na pasubot si architect may column dire. So ang imong choice is i-rest ang imong beam sa another na beam. So ang imong section dire may girder na da. Pero sa tuma may ara ka sa column. Okay, ang concern dire is member built integrally with spandrel. Ang isa is supporting column. So if ever ga-rest ang atong exterior beam, ang atong gamiton dire is if resting sa another beam, that is a spandrel beam. Okay, if resting sa column, that is WLN squared over 16. So since all exterior supports, okay, they are resting sa column, so ano gamiton ta? This is WL squared, LN1 squared over 16. Negative W L and 3 squared over 16. Tapos na. Interior face of exterior support. Next. This is exterior face of first interior support. Ano sir ang first interior support? Din ang interior support nila. This is our interior support. This is our interior support. These are ang first interior support. In reference sa itong exterior side, ang first interior, okay. Okay, in reference sa itong exterior side, ang first interior, okay. Ano sir ang other instances? So let's consider these 4 spans. Okay, we'll have exterior support. We'll have exterior support. May interior support dire, interior. Tatlong interior support So we'll have our first interior support near the exterior face. So this is our first interior support. In reference sa inyong right side naman, ay ang first interior support. Ano na siya? This is your second interior support. So initial location is at the exterior face of first interior support. So ang first ng interior support, yun dire. Ang first interior support. Okay, ang iya nga exterior face. Diyan ang exterior face dire. Ari or ang ari? Ari or ari? Ang ari sa left side, no? Sige. Okay, so ano ganito natin? May duwa ka kondisyon, 2 spans ka, more than 2 spans. So since ang ating continuous beam, this is a 3 span. So we'll use more than 2 spans. So that is W. Erase na nila sa talo. LN. Magamiton. LN1, puno, tanay. Ha? Negative. Over kailangan over 10. This is negative W ln 3 squared over 10. Sakto ni yun din. We'll have a footnote. Dalawa din. Footnote na.
Ano ba lang exterior? Ano ba lang exterior?
Calculate. Sorry.
Exterior. Interior.
Calculate negative moments. Okay, between adjacent spans. LN shall be the average of the adjacent linear span.
Dari sa katulog, di ba?
So since ang aton na negative moment is found between these two adjacent ends, may LN1 na mukag, LN2. So dito na dire is not our LN1. Average lang. Is there an exterior, sir, na wala tayong average? Kaya wala ba siya sa adjacent span sa iya nga other side? Okay? So therefore, for this moment, this is W ln1 plus ln2 over 2 squared over planning over 10. Negative W ln2 plus ln3 over 2 squared over 10. Sir, saan o lang pwede mag-average? If ever ang inyong negative moment is bounded by two adjacent spans. Except no, sa itong exterior span, kaya wala ka man isang adjacent span. That's why yung gamit na is LN3. Ang duwa lang na span, same ang Japan. Ang inyong first interior support. Okay, clear? Exterior plates of first interior support. Duwa condition, either 2 spans or more than 2 spans. Ano nga po sa part? Tanang na negative movement na face of other supports, automatically this is 1 over 11. Anong bilhin na rin na wala sa value?
Interior face of interior span.
So, gusto mo na page na siya, interior space of ano? Kasi ba may mga values na nila? Exterior, first, exterior face of first, interior support. Same. This is negative W ln1 plus ln2 over 2 squared. Bilang ang division dahil over, that is over 11. Again, negative W ln2 plus ln3 over 2 squared over 11. Okay? So complete ng inyong moment values at the-support kag positive moments ang inyong continuous span. Okay, no need mag-MDF. Okay.
Yay!
That is, if na-satisfy mong imo nga 5 visions. Okay, what if, sir? Sa live load. Matapuan na gid ni nga 100%. Okay, what if mo live load is 75%. Mabuhin ka sa imo nga uniform load. So hindi siya pwede magamit. Itig mo tama gamit mo lang if ang inyong uniform load is existing all throughout sa inyong length. So di siya best pwede magamit sa one-way slab na continuous. So what mo, paano ka mo mag-analyze one-way slab? Diba ang inyong assumption is simple span. But actually inyong slab is continuous, so pwede mo magamit ang NSE 815 provision. So we will discuss by Friday one-way slab, two-way slab.
Wala ano, oras na mo sir?
Ha?
8
Okay na? O, share naman ta.
Share mo lang.
Ha? Tapos na lang ang deadline. Tapos mag-rate ta. Win naman ka si Smith. Okay na. So we'll have approximate shares for non-stress continuous beam and one-way slab. Sir, what if two-way slab, one-way slab? Magaling lang ang two-way slab. One-way slab na lang. Sir, what if two-way, one-way? Okay. Qualification, exterior face of first interior support and face of all other supports. Okay, manotice ninyo, same lang atong ginagamit, di ba? Kung shear, W, or uniform load multiplied by length. And for our movement, uniform load multiplied by the square sa aton na length. Okay, so instead of writing this, kung natin is, isulat na lang ang coefficients. So for our shear, the ang exterior face of first interior support. Yan ang first interior support. This is the first interior support. First interior support. Then ang exterior face. Ari ang exterior face. So gamiton ta is, since this is a negative shear, so that should be negative 1.15 over 2 ang iyang coefficient. And the radius is positive 1.15 over 2. Then face of all other supports is 1/2. This is 1/2. Negative 1/2. This is negative 1/2 shear. Okay. So I will give you an assignment regarding continuous beams ng other cases aside direct. Okay, and sa one-way slab. Okay. Next week.
Friday, sir?
Next week is goods na? Let's go back sa ating target na value or I mean the reward for this problem. Di ba? We need to identify pila ang MU at the supporting. Okay, so paano, ano kinakailangan natin na direct? First, need natin ang moment due to dead load at E. Second, we need the moment due to live load at E. Tapos, moment due to wind load at E. Tapos, moment due to earthquake load at E. Okay? So, sumahon na ang moment due to that load at E. Okay, sir, iba niya, sir. Ako na may tao na ito kay we don't have enough time. No? Ano lang sumahon? Moment at dead at E. Anong atong na value dito is negative W that load natin is ln1 squared over 16. Ilang uniform load at sa dadganin that is
17.973.
17.973. ln natin is ilang ln1? Minaraise 8.05 no? Over 16. Ilan siya? Negative 72.7935. Moment at light. Same lang dapat. So negative uniform light. Sir na ay sir sa NCG na bali ang W. I-consider na ang load combination sa kag light na 1.210 kag 1.69. Kaso ground na diyan, combine na po sa wind to seismic. Ako na again, unfactor na siya for service moments due to dead kag service moments due to light load. Okay, kaya iya the assumption is only gravity load. Ako nang iya ang factor uniform load, ang factor shear, and also your factor moment. Live load is 9.4701. See? Pala ni.
38.355.
40. Tapos na ta sa dead live.
Take a break, sir.
Ang live load is case 1 na niya. So syempre, sir, what if kung may live load case 2 nga 75%? O, i-analyze mo sa liwat, kung nung ino nga moment acting at point T. Kaso, you can't use this NSAP 2015 provisions anymore. Okay, diba? Kung mag-live load case 2 ka, ang imo nga live load is i-reduce mo by 25%. Imo nga live load case 3 that is 50%. O, so, hindi siya pinamagamit. O, anong inyong gahon? O, gamitin ninyong other methods for indeterminate frames. MDM, SDM, portal method, deliver. Okay? Letter B. Design loads and structural analysis. This is for lateral loads. Okay, so let's have a short break. The time right now is 10:09. 10 minutes lang, 10:20 balik na. But at the same time, kung may free time ng subok, kindly review. May pa-review ko. Hindi pa nag-hold na tayo. Kindly review approximate analysis. Tunggang ka muna eh?
Yes, sir.
Okay, first meeting sa still, di ba? Second meeting. Tapos, kindly review also portal method. Ito ko nila, paano ng portal method? Okay, let's start be back to live load case 1. Even though we will have live load case 2 at live load case 3, for our problem sa load definition na to, we will only consider isa lang ka live load case. Okay, so let's proceed on twin load. So for this determination, sa moment at lead, we will consider only one load case. Ilan na kami ang gawin sa problem. Okay, so for our twin loads, we will only consider one load case, wherein the prevailing wind direction is perpendicular to edge. If this is perpendicular to edge. Second, we use only the lower bound value of external pressure coefficient. So we'll use CP2. Tsaka lang CP2 lower bound natin. Then we'll use a positive value for the internal pressure coefficient. It is positive GCPI. And we have the following parameters. Okay, so dito sa wind load. So atom na wind load will only have two prevailing directions. So first, we'll have our wind blowing perpendicular to ridge. Second, ang atom na wind will blow parallel to ridge. Okay, ang mga sa load case, wala siya kabilog. So for this problem, perpendicular to ridge. Next. So for each frame, we'll have 8 cases. Sa 8 cases na doon, ang first 4 niya, this first 4, this is the condition wherein the wind is blowing perpendicular to which? Okay, ang first 4. Second, this is parallel perpendicular and parallel. Perpendicular to which we'll have our windward side. Dum-dum mali. Okay. Windward side, yeah. So this is windward side. Windward side. Windward. Okay. Then, this is your side wall. Magwashing ang hangin. Start ko lang ang corner. Tao na. Silaw. Tao na. So lang magtapos. Okay, we'll have our side walls pagkuha ang hangin. O pagkuha ka ng hangin direct. Therefore, for this first case na perpendicular to ridge, these are all windward side of your building. Okay. Then these are all your side walls. Side walls. Side walls. Then the other side is your leeward side of your building. Okay. Sir, paano ng 4 cases under the perpendicular to ridge? Paano siya nag-4 cases? So for this first two, di ba, we'll have our roof loads. Okay, sa mga roof loads, we'll have duwa ka external pressure coefficient. So let's consider dire, we'll have our CP1 in sa roof, and we also will have our CP1. Okay, and dire, for our roof load, we'll consider a roof load na CP2, tapos dire, CP2, or the lower bound values ng ating external pressure. Yota, perpendicular to ridge up at the base. Wherein ang first two is, same lang siya na windward, side walls, and leeward. Ano nang deeper dali? Sa first two, CP1 gamit. Sa second two, CP2. These are na duwang na CP1. Kaya we will consider also the effect sa, this is the positive na GCPI. Tapos this is the negative GCPI. Dali. We'll have also positive na GCPI. Dili, negative na. That's why 4 cases per hour perpendicular to ridge. Next, parallel to ridge. The wind is blowing at this direction. So we'll have our windward side. Dili. Side walls na pagkuha. Side walls. Leeward. Okay. Therefore, tanangin sila is our windward wall, windward wall, windward wall. Side wall ni, tapos ang side wall. Same pattern na rin. So for this first two na pairs, ang aton na parallel to ridge, we'll consider an external roof wind pressure using our upper bound value sa CP1. Okay? We'll use also CP1 direct. Sa CP2, CP2. Okay? Wherein this first CP1 will use a positive GCPI. This is negative GCPI. Very positive GCPI, negative GCPI. Okay, so in general, we'll have 8 cases sa paghuyog sa hangin regardless kung longitudinal or transverse frame. Amo siyang 8 cases. At least mo sa 16, and it will have duwa ka training. Anong first category natin? We'll have perpendicular to ridge up at the base, parallel to ridge up at the base. Okay, for perpendicular, duwa case na CP1, okay, duwa CP2, wherein they are distinguished by their internal pressure coefficient. So in total, this is the 8 cases of your window. Next one. Next yun. Malota, duwa ka prevailing direction. Perpendicular kag parallel. May apat kong case na rin. Wherein siyang apat na case is classified into duwa ka roof pressure, kasi syempre di ba roof pressure na may upper bound kag lower bound. Pero ang inyo yung mga walls, ang inyong windward wall, side walls, at leeward, same na sila all throughout. Okay, sa daling apat. Anong ka-differ dali? Ang first two, lain ang ilang external pressure coefficient for your roof in the upper bound. The second two is the lower bound value of your external roof pressure coefficient. Okay, since duwa na sila, we'll use first the positive DCPI and sa second is the negative DCPI. So, same ang apply sa parallel to which na. Okay. Then masulod sir, ang amon nga load pieces. So for wind load 8 kg, amon yung ilang external and internal wind pressure. So for our critical frame along the longitudinal side, okay, so this will be your load pieces. Okay, diba this is your critical frame along the longitudinal. So may 8 pieces na po. So for your piece 1, that is perpendicular to ridge. So case 1 ninyo, anong iya hangin sa iyang sides? Side walls, diba? Side walls, and iya roof is CP1. Then nagamit kami sa internal pressure na positive. Case 2. Case 2 is, same ang Japon, ang iya sa kilid is side wall. Pero iya roofing is positive CP2. I mean, the lower bound value of your external pressure coefficient for your roof. But ang gamit nimo is positive na CCI. Then ang same apply na rin, wherein negative ang iyong CCI. The next 4 cases, so case 5, 6, 7, 8. Case 5, parallel to ridge. Okay, this time, sa inyo naman na side, sa inyo na transverse plane, ang color red na, ang ga-axis na is windward, na wind pressure ka, leeward na wind pressure. Kaso, ang gamit ninyo is the upper bound value sa inyong external pressure coefficient for your roof using positive na DCPI. Dere, same ang Japon, ang inyong na windward, hindi na siya mag-change ang iyang magnitude. Ano ka-change dere? Ang magnitude sa inyong roof pressure coefficient, which is, yung gamit nyo ang inyong lower bound value na CP. Okay, using the same positive GCPI. O, same ang dere. Okay, wherein ang inyong gamit is negative na GCPI. This is a total of 8 load pieces for each frame. O, this is for your longitudinal frame. This is for your transverse frame. O, for this problem, ang gamiton ng load case is only the wind load case 1. Okay, wherein this is perpendicular to ridge. Tapos, ang atong gamiton na external pressure coefficient for roof is the lower bound, CP2. Tapos, positive DCPI. Okay, so since we are analyzing our longitudinal frame, okay, this is perpendicular to ridge, so dito ang pinasa-apat. Tapos, that is a lower bound value of external pressure, CP. So, CP2. Tapos, that is a positive DCPI. So, this would be our load case for our window. Let's try to visualize our load distribution. Isa lang yung case only one case. Okay, we don't have enough time to analyze all cases. Okay. Let's consider ang hangin, hindi siya loyo. So for our longitudinal frame, anong ma-up na rin sa sides ng building natin? Ano siyang hangin na rin? Diba side walls na lang? This is perpendicular to ridge. Okay, so sa sides ng longitudinal frame, side walls na lang. Okay. So side wall na rin. Hindi lang, ito lang. Side walls. So uniform, di ba? Uniform. Din ang ground level na yan. Siyempre yung hangin, dapat asta lang sa inyong ground level. Kaya wala ka bang hangin sa tuta, di ba? Yung side walls, ano di? So this is your uniform load, okay, at your side walls. Then ang inyong roofing, hangin, di ba this is the windward side. So the effect ko that sa ating framing, okay lang i-erase na tanan. Ay kita na gawin. Erase na.
Board.
Whiteboard. Ibang TV sa table level. Di ba this is perpendicular to ridge? Tapos we use CP2, then positive AC, PI. So we all know, ang atom na wind loads, ating critical frame na, this is our critical frame. This is our longitudinal frame. So ang loading sa, since the wind is blowing at this direction, so windward side na, so wala effect ang windward. Okay, i-ari siya sa size ng inyong building, ari inyong frame. So ang ating focus is, ari din. So for the two sides ng ating longitudinal frame, we'll have our side walls na wind pressure. Considering a positive na internal wind pressure. Ang acting sa atong roof level. So since the wind is blowing at this direction, perpendicular to ridge, ano yung kanya natin kung flat ang roof? Di ba kabari ang aton na wind pressure from the windward side going to our leeward side. So for our roof pressure, ang lapit sa windward side mas dako, di ba? Nagkaroon ng idea kung paano may percent ng inyong load pieces. Hindi ba you'll have your preliminary design by the end of your semester? Ano inyong final defense din eh? December. Pero I think inyong chapter 2 deadline is October
31.
31.
Before editing.
Diba kabari? Kabari siya. Yes. Tapos malubog. May question, sir. Anong gamiton dinamon? Kit pa na ito yung value ninyo? Gali-trace siya? Ano kami nanamon, sir?
Ang dako.
Ang pinakadako. Diba this is just representation sa critical loads. So, we will use also the most critical values ng inyong CP at your roof. Okay, gamiton na pinakadako ang CP. Okay, erase naman yan. Para mas ma-understood well between the CP1 and CP2, di ba? Ang ating CP1, this is our upper bound, no? Upper. CP2, this is our lower bound in reference sa atong na positive kag negative. Paano na, sir? So technically, if atong na CP is both positive, this is let's say positive 0.25. Ang lower bound mo is still positive, this is 0.18. Siyempre, ang upper bound CP1, this is the lower bound CP2. Next, what if sir positive ni 0.18, lower bound mo is negative 0.18. Siyempre, mas lubo, di ba, ang negative? Okay, what if sir kung both negative? Ang question ko, 0. Ang example, 0.9 kag negative 0.3. Then ang upper bound, the lower boundary. Dapat ang upper boundary is negative 0.3. Okay, mas lapit sa 0, mas lapit sa positive. This is negative 0.9. Okay, maniruling ta sa upper bound kag lower bound. Okay, para ma-emphasize ta, ang atong na lower bound, mas inclinated siya sa effects ng suction. Hindi ba mas lubo yung positive, more on suction siya. Okay, going to negative 0.9. Okay. So let's consider our CP. For our CP, diin di ato ka CP1 o CP2. Kaya for this problem, we will use the lower bound value. O, anong lower bound na natin? Mas layo sa 0 o negative. So this is our CP2 and CP1. Okay? And we have emphasized na dito sa value of CP2 is the extreme value niya. This is a negative 0.9. So we'll have our uniform load sa roof deck natin. Uniform load okay, sa roof deck, imuon ko siya roof deck 1. Tingaan. Then aton uniform load at roof deck 1, we will use, CP2 ganito. Roof deck 2. Okay, we will use the value of our CP1. Uniform load sa roof deck 2, we'll use the value sa CP2. Okay, syempre side walls, fixed na siya. Also go out, di ba? Okay, goods. Goods na yun ah. Ako na iyan, may pamanggot ng mga nasigay. Anong next na din na sumahon? So since ang aton nga roof framing, okay, roof deck lang ta, so ang aton nga H is pila. Okay, wala ta roof angle ha, flat at roof deck. So ang H ta is equal to o, detakso ng H natin from the ground level, ground level up to sa aton nga roof deck. Okay? Sa H natin, sila na siyang height niya.
That is 3.6, 3.5, 3.5.
Ang framing, syempre, mahal sa frame. Pag ang hangin, di ba, gawin ka na about the ground level. Ang ilang H, 3.5 times 3. Planet. 10.5 meters. So therefore, ang atom na H is equal to 10.5. Okay. This is the effect of side wall. This is side wall, array, roof, na using CP. Okay, anong needed natin magsuma sa aton na wind pressures dali? Diba kung sa windward side, we need to evaluate our wind pressures at every floor level. So since ang aton nga gina-analyze is the side walls of roof, ano gamiton ta nga velocity pressure Q? Need natin ang value sa QH. Okay? May si QH, pwede magamit side walls, leeward wall kan sa roofing, except sa aton na windward. So let's evaluate our QH. It's 0.613 kz,
KZE, KD, V squared.
Patik mo ta, ang kz ta is equal to tatong ng k. And we are evaluating the velocity pressure at height h. Paano magsuma sa ating kh? Ano tingnan rin natin? Exposure is exposure B. So for exposure B, then exposure B.
Interpolation.
Ang height at 10.5, so interpolate ka no? So that is 0.76 minus 0.7, 12 minus 9 is equal to 0.76 minus kh all over 12 minus 10. Ilang aton nga kh?
0.73.
0.73.
0.73.
73. 3.
Given ang KZT, this is equal to 1. Ang KD na given na also this is equal to 0.85. Basic wind speed ta,
60.
lato to 60 no? So 260 kilometer per hour. Okay, 1,000 meter all over 1 kilometer.
72.
1 hour 3,600.
72.
Ilan?
72.
72.22. Okay, so we can now evaluate our velocity pressure at height h. Sir, wala na sir na evaluate niya h floor level. Di ba? May h floor level na din. Okay? Oh, kaya nga itong wind load case is only perpendicular to ridge kag CP2. Kaya ang gaak sa itong side sa mga framing, sa longitudinal frame is only our side walls. So if ever, ang atong case is parallel to ridge. So there is a possibility na you need to evaluate at each floor level. Okay. So always refer sa inyong mga 8 load cases kung paano nyo i-cluster ang inyong load case. Take note na case 1 lang ato na i-analyze. Same sa live load na only case 1 will be analyzed. So let's solve for our QH. Bilang si QH 1988
Pascal.
1.9839. Goods na goods.
Good.
Next, we need to identify ang atom na total pressure acting sa side wall kung sa atom nga roofing. So for our total pressure, hindi siya nakita ang inyong equation. Your equation P is
QGCP.
basta muna sa P acting at your side walls is Q
QH.
G
CP.
CP
Minus.
QH. Yung P na nasa P or the wind pressure or the ceiling pressure Q
GCPI.
GC. Okay. So we already have the values ng Q na to evaluated at the meter of height. We have our gas effect factor and ano gamit ito nga CP ganit? The lower bound CP2 kaya amo ni ang indicate nga required for this problem. But for your project study, you need to evaluate all cases. Eh syempre wala nakabalo kung din sa O4 or diin makaproduce ang maximum factored moment at E at all liable cases. Okay? So we'll have two pressures. Pressure at your side wall at pressure na sa inyong roof level using our CP2. Okay, so P acting at our side walls. Okay, so this is QH. P will use CP2. Ngayon, minus QI. Then we'll use the positive na GC. Okay, may QH na ta. Okay lang ba sa CP2 ganit? So since this is going parallel to it and then normal to it, pero theta is less than 10, so gamitin ta ang main position. Okay, wala na check nyo. Wala na check. So let's check our H over L. Bilang H na ganit, that is 10.5. Bilang L na, anong L ganit? The length of the building parallel sa wind direction. Let's go back to it. Diba this is our case 2? Ikaw yung panghangin, narin consider sa mga L. Pila na yun ang naka-left sa framing plan lang. Consider na lang ang center. Ang center lang. Limited and below ko natin yan. Gamay lang ang inference ng center lang. That is 3.6 plus 3 plus 3.6 plus total yan.
10.2.
10.2. So all over 10.2. Ilan eh? Ilan?
1.03.
1.029. So gamiton ng H over L is hindi This is only for H over L na less than or equal to 0.5. So we'll use the greater than 1. Okay, anong iya nga largest value? Hindi siya, negative 0.9, no? Hindi siya. 1.3. Kasi direct ko kabilog. Hambal niya, value can be reduced linearly with area over which it is applicable as follows. Ha? Ano?
Hotso.
Ano kasi CP2 is equal to negative 1.3. Okay? But we can reduce this value of 1.3 sa iya na area na covered. Ano siya na area na covered? Using this. Ayan. This is your critical frame. We are analyzing our critical frame. And this is the area na iya na ina-cover. Sakto? Sakto din sir. Ano siya lang iniwan? Pag-sumat na kanina. This is our tributary area. And ang iyang area is kila to? 28.05. Pila your dose na? Uy!
0.5.
Interpolate na naman. So, let's multiply this by our reduction factor. Let's call this as R na lang. Okay. So, ang R na, since ang area na covered niya is our tributary area, that is 28.05. 05, that is between 28.2 and 92.9. Okay, so solving for R. 0.8 minus 0.9. Ang area covered is 92.9 less ang atong na 23. 0.8 ini CP2 ang atong ina-evaluate ang atong na reduction rate. Okay, this is the reduction factor. Over 92.9, ilang area na
28.05.
28.05. Liwat na sir na 28.05. This is your
Area.
tributary area. Okay, the area covered by your over which it is sir, in area sir, A to F ha? Hindi, bilogin. Okay, we are analyzing our pressure kalakasan.
Sulat na sir, Roy?
A to F lang na.
Bald, bed.
Blue ball.
Kaya mo siya example, ganyan itong sundo. Pakita ko lang kay Patrick is aware na ako. Kamunitawan. Awareness month.
The Joker.
Ilang atong na total area? That is 28.05. Hindi, ano lang eh?
So,
Bilang atong tributary weight yan eh? 3.3
Times mo sa
3.3 times ang total length natin. Kaya na yung total length ng 8.5 plus 8.5 plus
24.8.
7.2. Bilang area? 75 point
79, sir.
79.86.
Kumersa sa cleanser ako.
Ang problema that clear. So total area covered under this wind load that is 79.86. Okay, so we need to reduce this. Ang hininga natin 1.3 as defined by your code. That is 79.86. So bilang ato na rate of reduction R. Pila.
0.81.
0.8187.
8187. So final value for our CP2 is equal to negative 1.3 multiplied by 0.8187. Because CP2,
1.06
1.43.
0643 3.
Kulang pa rin, sir.
Low bat, i-charge na natin. Ano na ganito, nasa mga materi, hindi pa pinahamuha ko na. Okay. So let's solve for our designing pressure acting sa sidewalls natin. Okay, hindi para kasuma na doon ang ato na uniform load acting at your sidewalls. So P sidewall, AQH na is 1.9839. Kaya ang ating G is 0.85. Ang CP na is negative 1.0643. Okay, kabalo? Then ang QI ta, this is evaluated at height H also. So we'll use the same na velocity pressure. So that is minus 1.9839. May kalimtan ko ang given. Okay, so for this problem, ang aton
Partially
aton ni enclosure classification.
enclosed.
This is partially
Close. 0.05.
Enclosure is
0.55.
partially enclosed. Wala ka nabutang sa problem kasi okay. Sir, dinagalin sir enclosure classification given ang kulang lang. Kung aton na GCPI this is equal to positive negative 0.55.
55. Busan dito.
0.55. And for this closed case, we will only use the positive values ng internal pressure na. Okay. Pila na siya? So, QI, the CPI is positive, so 0.55. So, pila ang aton na wind pressure acting sa sidewalls?
Negative
2.88. Last, let's solve for your uniform load acting at your sidewall. So this is your pressure at your sidewalls multiplied by the sibitary weight sa inyong abel. Ano sa sibitary weight? Same ang Japan at 3.3. So negative 2.886 multiplied by 3.3 bilang uniform load sa sidewall.
Negative 9.523 52 52
Kilonewton.
Good.
Group, ay! Joke lang. Islat lang. R2. This is R2. R2. Okay, roof using CP2. Uniform load R2. Okay, kaliwat na. Ipakita ko lang anong ginawa ko mga mistake. So, back R2 na.
Kasi full squad.
sa gin-highlight ko sa PSL wala na.
Totoo na rin eh. Let's compute for the wind pressure at your side walls. It's QGCP minus QI GC. So bilang CP talaga for our side walls. Side wall for all values of L over B. So we'll use negative 0.7.
Wait, so much.
40%. Negative 0.7. So Q rin sila. Kasi Q. QH. QH. 1.9839. G is 0.85. CP is negative 0.7. Minus, the QI that is still the same, evaluated at our midterm height. That is 1.9839. We will use a positive GCPI that is positive 0.55. Kailangan natin mag-design ng pressure acting sidewalls natin. 2.27. Last, uniform loads acting sidewall natin sa our sidewall and sidewall pressure multiplied by our unitary. Negative 2.716. 8.3. Ilan siya? 4.963. Emergency brake to nanay. Ma-charge na ko. Ma-charge ko sa marker. The magnitude for our uniform load acting sa the side. Isang matulong nila frame which is your side wall effect. Ang iyang magnitude is kami. Negative
14.805.
14.805. Ari also is negative 14.805. For our roof, that is negative 0.523. Sa liwata, ang concern na dali, we want to know pila ang moment acting at face of column A sa BNEF. Okay, kaya mo need tayo load combi together with our moment at then. Okay, at point A at moment at time acting at sa atin na point A. Paano na sa sumahon? So we introduce reintroduce ang inyong previous topic. This is approximate analysis sa gravity load. So lang ato nga, for time 14. 7.
Ay, parehas. Sorry.
Negative 7.9.
So, wait, nagalit. 463. Sorry, sir. My false.
So, example sa 7.9.
4963.
4963.
My false. Kaya parehas label, may na confusion.
Okay. Kasi wait.
Confucius pilot.
American explain.
Confucius pilot.
So for this framing, ang concern natin, we can't use this equation anymore. Okay, kaya ini siya, we can only use this if ang ating loadings are only gravity loads, which is that is your dead load kag live load. Then, ang ating na framing, this is composed of a vertical load, ang ating na lateral load. So, paano na siya i-analyze? So, pinaka sa tanan, we will use MDM. But, we will introduce or reintroduce again sa inyong theory 1, that is approximate analysis. So, in order for us to analyze our internal effects due to this wind load, hindi ba we'll have our external wind pressure acting at your roof level, then ang inyong with pressure acting sa size ng mga longitudinal frame. So hindi siya natin directly ma-analyze, but we will use the principle of superposition. Sipakon natin ang duwa ka load pieces natin. Okay, for this frame, only the loadings acting sa roof deck natin. Second, only the loadings acting sa aton nga lateral frame. Okay, combine natin whatever ang moment produced sa inyo nga moment due to wind load by this loading, then moment due to wind load by this loading, ang total ng moment acting sa aton nga point E for the wind load this one. So first, let's consider this loading. Kaya pa? Negative 9.52. So let's have our E and PH. Lingkat ko lang ah. Okay, so if ever ang frame data is only acted upon vertical loads, wala lateral load, we can use our Theory 1 na topic, that is approximate analysis. Okay, so let's have here our equivalent frame. So if ever yung mga girder is supported at its end, okay, both at A and B, ang i-column ninyo ang inyong girder. So ang aton na analysis na regardless kung upward or downward, ang effect sa aton na moment diagram. So this will be the location sa points of zero moment. So this is approximate analysis. Okay, take note that we can only apply this if ang loads are distributed all throughout the span. Okay, hindi siya pwede magamit if ang loads is isa na kasuhan. Let's say, may load din, wala dali load, tapos may load liwat. So dapat uniformly loaded siya. So assumption din, this is the point of contraflexure. Pag wala ka bilog, this is your shear diagram, shear diagram, tama na. Then, ang inyong moment diagram. Okay, sinak ko na. Ali, this is called as your point of ano nila, ne? Ali. Point of inflection. So the end, the for ang zero shear, thus producing the maximum moment. Ang Ali naman niya, this is the point of contraflexure. Dili ka shift ang inyong bending moment from positive bending moment going to negative na bending moment. Ano na iya significance? So usually, ang inyong point of contraflexure, if may ara ka mo sa tawag ni inyong elastic curve. Sa inyong elastic curve, dili ni siya ga horizontal. Right? Tukumon mo ni siya horizontal din ang inyong elastic curve. Okay? The location of your point of zero moment, if both are fixed ends, okay, that is located at 0.21 L. Considering ang inyong beam is the only one na flexible. Kaso syempre, ang atong column, may property siya that is a reinforced concrete. So it has a modulus of elasticity. Pwede mag-bend ang atong concrete. Okay? Considering the flexibility sa concrete natin, ay sa column natin, pwede siya mag-bend rin. Thus, ang atong final location, considering the flexibility of beam, the flexibility of our column, the final location zero moment is 0.1 L. Okay, wherein your L is the on-center spacing. No? Kaso, sa atong analysis for our reinforced concrete beam, we consider ang atom na length as the clear spacing. So for this problem, we will consider Ln. Kaya ang atong allocation sa moment is acting at the face of our column. Diba ta? Ang gamiton ng L dire is our clear spacing. Okay? So, anong significance ng zero moment? So ang atong zero moment will act as a hinge. Okay, may internal hinge na. hindi ba sa atin nga hinge, wala na sa moment mistake na property. So since zero moment siya, pwede siya mahimo as hinge. So this would become a composite body. So ato na final representation din hinge. 0.1L, 0.1L, ang inyong mga 0.1. Goods. So let's represent that here.
Sir, for once, please tara.
Kaya ka?
Kaya mo. Kaya, no?
Wala ka mo no choice, no? Mababang load, anong moment na nito? Magalaw siya. Alipa mo na. Ang target na, the moment at A. Isa liwat, ang ato ni gusto i-load kong B is the moment at A na dun. Since this is a fixed support, dapat tatlo reaction na dun. Okay. Wind load using a vertical lang. Okay, lateral lang. PE, vertical downward. This is your reaction at E. Same as the rate.
Number 3. 4.
Ano kita?
Let's consider a hinge. A hinge. My hinge to my hinge. Ito consider what the length is our clear length or our clear span. Kasi ang ating in-analyze earlier is at the face of our column. So the total length in ano lang yung length natin?
8.5. Feeling ko kung
This is 8.05. Okay, ilan yung length? This is 0.1. 8.05. This is 0.805 meter.
Old Bentley. Imagine ako.
Ang pinangbilin? 6.45.
Sa peak point.
Ang unod niya. 312 sa first hour. Yung buwan nila na rin sila plan yung butang sa kapit. Yung pagkatira, yung buwan nila yung butang sa lakes. Kita mo lang ang W12.
Yan ang gusto na i-label din.
Ang W12 ko pa ang masaya.
Ano na label? Sabihin na ito na
Paano mo ganun?
1.1. 0.1 ano? 0.1. 0.2.
This is the HM2.
Kung may vertical na
HM2 niya.
so we'll have
Piston.
8.1. Yan o.
Sinagamot para di mo mag-shot. Di mo sinabda mo.
May X na naman po eh.
Complicated.
May para ma-label mo siya as X mo may X at XY. R1 na lang. R1. Basta mo niya i-press no?
Opposing piston engine.
Siyempre yung horizontal yan.
Piston. Linkage. Crankshaft. Linkage. Piston.
May pin siya.
Malim. Isa ka lang po.
Tawag ko niya as R1X, R1Y,
Gado.
R1X din,
Isa lang po.
Mas simultaneous na dapat.
R2Y, R2X.
Pinay siya galing. Pinay.
Complicated na siya.
Oh, kaya pa?
Kaya mo.
Oh, yes sir. And yes. na naman. We need the value of our R1Y so that we can solve for the values ng aton na FEs. Pwede ba kung mag-sum ko some moments about A using this FBD, pwede ba ma-cancel out ang R1X in PE, ma-cancel out ang reaction at E, mabilin ang R1Y ang inyong reaction dito. So masuma natin ang FE natin for this case pa natin. Okay, may hapas na natin na lateral load. Question ko, pila ng total na vertical reaction? So, master na yung statics. I'll consider this first FBD and I'll call this as FBD1. Ari is FBD2. Flashback. FBD1. Okay, summation of movements about data. This is point 1, no? This is point 2. Summation of movements there. Sa point 2. 1 to 0. Okay. So, nabilin R1Y, no? So, R1Y, that is counterclockwise, so positive. R1Y, moving arm is 6.44. Minus ang ating reaction na that is 9.5238. Ating length is 6.44 multiplied by 6.44 Pila si R1Y? 30.667. So, itong assumption na going downwards. Next, let's consider FBD2. In Arik, it's our FBD2. Then, the masam moments. Summation of moments at point B. Assuming all cover comforts positive. Okay, so we have our FE, negative FE. Tapos, and then within. Our reaction, that is 9 point, positive, no? Positive 538 multiplied by 0.805 over 2. Then ang atong R1Y, that is positive also. So R1Y is 30.667, movement arm is 0.805. Ilang atong ng R1Y? Sorry, moment at E. Okay, I'll call this as ME1. Okay, and this is our first movement due to the vertical loads only sa window. I-add natin ang effects sa natin na lateral load. Okay, this is ME1. So we now have the moment that is due to this loading. So i-add natin sa moment induced by this lateral load. Ano gamitin natin dire? If purely lateral ang loadings natin. Let's reintroduce again your theory 1. So this is portal methods. Portal method, lateral load of building frames. Wherein assumption that if ang atom na building is fixed end at the bottom, there is an internal hinge between the mid height sa column ninyo kag mid span sa inyong beam. Okay, may hinge dali. So ang assumption is this is ang location sa inyong zero moment. Due to lateral loads. Okay. So ang total ninyo lateral load to be resisted, acting or acted by our lateral load, we will have your base shear. Okay, so for your each column ninyo, it will resist a horizontal shear na B. So if ever ang inyong framing, you will have an internal column. Yung internal column ka. So the total effect niya, duwa siya column. So that's why ang inyong internal column, ang iyan na resist horizontal load is 2D. May mga mo din before, theory 1. Review lang. In summary, the portal method for analyzing fixed support building, kaya ang building is fixed support at 2D. Requires the following assumption. So hinge is placed at the center of each girder. Okay, since this is assumed to be a point zero moment. Second, a hinge is placed at the center of each column since this is assumed to be point of zero moment. And last, at the given floor level, the shear at the interior column hinges is twice that at the exterior column hinges again. So let's analyze our framing for the lateral loads. For wind load, phase 1. Yung chasing naman. Ha?
Uy, kaya pa.
Napakita ko lang ha, labod line map approximate analysis. Ano pinaka-boss? MDM. Sa MDM, di ba? Makasumba ka lateral, ka vertical, kaya tumag na yan sa sideway effect. Or I mean, reintroduce mo ang ilong na
Ano ba sa sci-fi. Tabunan. 60 minutes. Property office.
Yan naman. So this is our framing and loading diagram for the second part. Okay, so i-add natin ang moment induced by this vertical load and moment induced at point A by this lateral load. Okay. So assumption is may pin dire, may pin man dire, may pin. Okay, yung layer, mid-length at mid-height. So kinakailan natin para masuma si point A, ay lang papangkulitan na. Kaya mo kung wala, naka-portal method.
Yes.
Sana di ba naka-portal method?
Sir? Yes, indeed.
Sir, kagawa ka ni sa boards? Yes, kagawa.
Oh my God.
Bilang floor to floor height, ganit liwat?
3.5.
3.5, okay. Ano na 3.5?
Hindi. Ayaw sa ako. 10.5.
And ground to foundation is 2 meters. No? Okay, kung half sine. Pin. Bilang half sine?
1.75.
Sir, paano ni Sir i-interpret or i-analyze ang among na loadings if ever may lateral load? Okay, we need first to distribute our lateral loads acting at each floor level. So, hindi siya may uniform load, kinanglan na siya i-distribute na rin at each floor level natin. So, we'll have our equivalent sa roof. Let's call this as FR. Okay, hindi may FR man. Okay. And this horizontal force acting at every floor level, this is called as your story shear. Alat ha? Ang yung tawag na story shear. Okay, the total shear force, the total horizontal force acting at each floor level. Ano ang story shear din? O, paano magsumas ang inyong story shear? Siyempre, ang inyong tributary wave na acting at your roof level is ari lang, di ba? Hindi lang siya located. Same on the rin. Ari iyang tributary wave, that is 1.75. So solving for our FR, this is equal to our uniform load multiplied by 1.75. Same on the rin sa aton na third floor. So let's have our total horizontal panel. The total story shear acting at your third floor, this is your F3. Ano yung story shear. Ang iyang military width is half man sini. Lagi siya. Kailangan this is also 3.5 meters. So for your F3, that is the uniform load multiplied by 3.5. Same as sa piyak tali. So you'll have also an equivalent of F3. Okay, ang iyang military width. Maximum. Last. 8 and so on. Sir, question. Sir, may bilin pa, di ba? Di ba si F2 ang iyang secretary with din? Ang muna yung shoutout. Ang muna yung secretary with. Ang muna yung na-cover ni F2. Ang iyong na-cover ni F2. Kay F2 ni, kay F3 ni, ito, ari kay, hindi na partihan na yun. Okay? So let's represent our FR. So may FR with the day. We'll have also FR. Limata, tanang collateral loads must be distributed every floor level, and that is your story shear. So for our wind loads, if ever may loadings ka mo dali, kinanglan nyo siya kwa as equivalent nga horizontal force. Kapit na, diba? Horizontal force acting at each floor. Okay? And that is your story shear. And this is our idealized frame wherein isipak natin na pin. So, from the principles ng aton na portal method, we'll have an equivalent horizontal shear dali. So, for our exterior columns, we'll have our B. Then, for interior columns, this is 2B. Spoiler alert, kabalo kung 0 ang B. So, let's solve for your FR. FR is equal to, ilang uniform load din natin? 7.4963 multiplied by 1.75. Pilan eh? Yes, so ito 13.1185. Okay? So summation of forces horizontal is equal to 0. Okay? Assuming all going to the right is positive. So negative FR plus positive FR, pila ka billing? 1, 2, 3, 4, 5, 6 feet. Equal to 0. Makancel out ng FR. So, B is equal to 0 kilonewton. Nakancel out siya. Kaya tungkol, ang inyong windows are acting at both sides of your building. Unlike later on, kung may later pa, makalambot na sa earthquake, ang earthquake na is, isa lang yaka horizontal force acting at each floor level. Anong inyong ma-assume na rin? Sumako dyan. Pin niya, pin. This is pin, this is pin. Pilang lengths niyo? Ay, pilang niyo? On center na line. 8.5 on 8.5 over 2. This is 4.25 meters. Lapit na lang na. Lapit na lang na matakpan. So, maintain pa din. Maintain. So, this is our FR. Okay, then aring nyo nga point E yan. May point E na mo da. Let's call this as point 1 and point 2 also. So we have sa equivalent at horizontal reaction to vertical. So we'll have our F1y and this is our F1x. That is equal to 0 kilonewton. Okay, this is your horizontal component no, sa reaction sa inyong column. O sa ibang direct. So we'll have our F2y, tapos this is F2x. Summing all forces. Diba this is equal to 13.1185. Okay? Ano kinakailangan ta para makuha ang moment about E? Diba this is 4.25. What assumes F2y? Moment sa 1. Summation of moment at 1 also 0. Sakto? Ano bilhin?
Sa tutuloy ito na isa lang missing, sir.
Ha? Kaya ito y needed na para makuha si moment at E. May drawing pa.
May 2x naman.
May F2x naman. Kaya po correct. So negative 13.1185 plus F2x. So F2x is equal to 13.1185 kilonewton. Tapos moment at 1 equal to 0. Okay, so we'll have positive 13.1185. Moment R is 1.75. Ano ba din?
Sir.
Plus.
Sir, question.
Hindi na negative sa
Then, dire.
ang marks pag
FR.
hindi na negative ang 7.4
I need to consider mo lang yung magnitude niya. Tapos, ano pa? F2x, no? So, F2x is 13.1185. Sumama ko si F2y. F2y is positive mo, di ba? Plus 4.25 times F2y. Ngayon, si F2x is minus 13.1185. Ito anay na lang 1.75, sir. Plus F2y equal to 0. 0 next. 0. Aking point E, liwat ang ating analysis is we are analyzing the moment acting at the face of your column. Okay? And we will have on-center spacing. Amunin inyo nga 4.25 meters. Okay? Then we'll have your vertical component here. This is your F2y that is equal to 0. Natakto to ng interpretation. Pila aton nga moment arm dire. 4.25 minus 0.45 is the weight of your column over 2. Pila na eh? Yes. 4.05. 4.025. So we'll have our moment at E2. Moment at E2. Yung may ME1 na tayo. So ME2 equal to F2y multiplied by 4.025. Isang kabalot na 0. Let's do this properly lang. Okay, we will use this figure later on sa itong na earthquake. That is 0 kilonewton meter. Therefore, ang final na moment, a moment at E due to our window is equal to ME1 plus ang ME2 natin. Okay, ME1 is 27.773 plus 0. 27.773 kilonewton meter. Okay? Anong assumption din? This is clockwise. May basta. Negative niya. Ito ka ba? May ato sa window. Sila ka? Uy. earthquake. Friday, alam ba? Parang energy. Questions? Yan ba, i-discuss na yung load combination. Mga at least may ilalim, mga
Panorama.
Galing stable. Ay, sinaris na nasa.
So for our load combi, kulang na sa earthquake na lang for load combination.
Dami ka nag-i-X.
So we have dead, live, wind load, earthquake load. First, we have our moment at that E. Siyempre, isa lang ka load case, di ba? Second, we have our moment live 1 at E. It is 1, this is 400%, di ba? We'll have also moment live 2 at E. This is at 75%. We'll have also moment live 3 at E. This is at 50%. Okay, ang nasumata is moment at that A, moment at live 1. Wala pa rin. Ano tayo ng next? Sir, nang itatlo mo lang. Depende nyo kay Sir Sedan ninyo kung pila i-require ng live 2. Let's consider moment live 4 E. This is at 25% na live load occupancy. Anong next natin? Let's have our wind load. Wind load case 1E. Kaya mo yung una tayong suma. Moment wind load case 2E. Moment wind load case 3 acting at E. Moment wind load case 4 acting at E. Moment wind load case 5 acting at E. Moment. Ito sulit ito. 6. 7. 8. Okay, 8 load cases per hour wind load. Aling dead. Sir dead. Aling mga live load. Aling yung wind load. Then last, for our earthquake, which is to be continued by Friday, a moment due to earthquake or seismic load 1 at E. Kasi syempre, di ba, mas wave building. Ang next I consider is moment due to earthquake 2, mag-reverse pabiyak. At E. Okay, this is your seismic load.
Uy, just make naman.
Anong after sini? Spoiler gamay.
God damn!
So for our load combi, we will use section 405.3.
Ang muna ko.
Ito doon
Yes, sir.
But we will use only a permission for concrete. We'll have 1, 2, 3, 4, 5, 6, 7 permissions. Sir, paano namin, sir, makuha ang MU? Hindi ba the required for this problem, we need to solve for the factored moment. The largest factored moment, di ba, we need to decide our MU. Okay, after makuha inyong largest MUA, ang lang inyo gamitin for your design sa rectangular beam. Okay, paano magsuma sila? So, we'll do all the load combinations. So, for our equation 1, so, kung talog yan, we need to solve for our MU at E. That is 1.4. I-dead ko lang ang kikapoy. 1.4 dead. Isa lang ang case, di ba? Plus, next equation. MU at E. Ano next thing yun? That is 1.2 dead plus 1.6 live. So, wala pa kamo sa roof live load. Wala pa kamo sa rain load. Hindi ba, ang consideration nila is dead, live, earthquake, at wind load. Plus 1.6 live. Kaso, kailangan live load case. But live load case 1, 1.2 dead, plus live load case 2, okay, this is your ML2E, plus 1.2 dead, plus live load case 3, 1.2 dead, plus live load case 4. For equation 2. So next, MU at at E using equation 3. It is 1.2 then. Wala pa kasang roof line load ka, frame load. Let's consider 1L or 0.5 with load. So we all know, ang ating na 1 na line load, hindi siya makaburn. May iba, ang ating largest is 1.6. So let's consider only ang 0.5 na wind load. Plus 0.5 wind load 1. This is your MW1E. Tapos plus 0.5 wind load 2 all going to 0.5 wind load. This is for equation 3. Ano pang bilhin? Equation 4. Equation 4 is what we write 1.2 bed. Tapos 1.0 W1 plus 1 line. Earthquake line. Diyan na, wala may load for na load combination na may earthquake ka with load. O imagine mo, no? Yung mga building, inalinugan na, nabagyuhan pa. Malas na yung gulo, di ba? Wala din. Malas na dead wind line, dead earthquake line, dead wind, dead earthquake. Kasi sa last two equation, wala na line load.
No, right?
Kaya dead na sila, di ba? Kasi grade ka na sila magtakas sa building. So wala na line load, ang inyo na lang ang gusto ko yung sa isang fourth equation, paano siya dito? Di ba may wind load ka, line load? So may line load 1 ka. So let's consider first line load 1. 1.0 line load 1 plus 1.0 wind load 2, wind load 3, wind load 4, going to wind load 8 for 1.0 line load 1. Next, plus 1.0 live load 2, wind load 1 ka naman, di ba? Okay, and so on. So, nakakasapot siya doon if mayara ka mo sa Excel program. O syempre, ang ato ni load combi, di ba isa lang ka load case? Okay lang mo? 1, 2, 3, 4. Sa inyo lang. Thesis, ano ba na, di ba? Questions sa window. Portal method. Approximate analysis. O din ba sa pos? MDL, di ba? Nakakakita ko yung MDL na, ano, Excel.
Wala.
Second set. So tapos diba, kailangan nag-burst dahil yung framing. Kung kailangan kayo yung framing na is, kailangan column isa, 2, 3, 4. Kailangan square meters na yung building. 4,000 square meters, approximately 1,000 square meters. O kailangan column sa isang frame.
Pero pag makalpo siya ng mga 12 months na
Kasi make sir, clear spacing.
gusto ka nito mag-plan. Kapag gusto mundo, wala lang mga
Okay, on Friday, we'll proceed with, I think we'll finish this first. Tapos we'll discuss 2 ways na design. May mga questions ba? Review niyo yung load combination ninyo pag-alter structural analysis. Kaya di ba kayo ang chapter 1 to chapter 2. So inagatang mo idea anong inyong direction sa inyong sa chapter 2 ninyo. Di ba chapter 2 is methodology? From your design load, going to your structural analysis, going to your design, cost estimates, tags,
A distance of ano, okay. Distance sa nearest.
tax mo more. Kaya na.
Tapos nursery, kung kailangan,